These are notes 1.10c. Again, put the date on it. And our essential question today is going to be multiple levels of factoring. So basically what we're going to be doing is, can I factor? I've been doing lots of factoring, but we want to factor when I can pull something out first. Before you even start, we're going to be asking ourselves, can I pull out a common term? Like maybe they're all even and I can pull out a 2, or maybe there's an x in everything or something like that. What I mean by that is just a quick little, let's bracket that off. If it's x cubed plus 5x squared plus 4x, you'll notice that before you even start doing any kind of unfoiling, that there's an x in each one of these terms. And if you have a highlighter, you should highlight that, because what we're going to do is, before we even start, we're going to divide an x out of every term. We're going to remove it, which will knock that down to 2 of them, this down to 1 of them, and this down to no x's. And then we're going to work with what's left. So we're going to be looking and seeing if we can pull something out first, and then we'll break apart what's left. So then we've got a trinomial that leads in a 1. So I only need to go to the back end. The only things that multiply to equal 4 are 4 and 1, or 2 and 2. And those are our only candidates. And remember to pick the correct pair. They have to add up to that middle term. So this one, if I broke that blue one down all the way, I have that x that I took out from the very beginning. And then the rest of it I can unfoil into an x plus 4 and an x plus 1. So that's what we are going to be doing here. I'm just going to do 3 examples with you of practicing pulling out a common term before I go any farther. So number 1, I'm going to give you 2x squared. I'm going to keep everything positive here for a little bit, plus 14x plus 24. And before I start trying to do anything fancy, I'm going to notice that every one of these terms is even. And if they're all even, which is usually the case, they're either even or multiples of 3, or they're usually not too bad. But if all even, remember you can divide or pull out or factor out a 2. So let's go do that. I'm going to divide a 2 out of every single one of those terms. You can picture putting it over 2 if you would like to. We're going to divide every term by 2. What happens is I end up with just x squared, because 2 divided by 2 is 1. And then I end up with a 7x, because 14 divided by 2 is 7. And then I end up with a 12, because 24 divided by 2 is 12. Then what I'm going to do is work with this remaining trinomial and see if I can break that down any farther. This 2 is going to hang along and be in my answer. The rest of this, it leads in a 1, so I don't need to worry about what's going on out front. I can just go ahead and I'm going to have an x squared. And then I go to the back and I figure out, well, how can I end this so that I multiply and get a 12? Could I do 12 and 1? Those don't add up to 7. Could I do 6 and 2? Those don't add up to 7. But 4 times 3 does, and because we're all positive here, I know that I'm going to have to choose a positive 4 and a positive 3. And so my factored answer would be 2 times x plus 4 times x plus 3. And I'm all done. You might need to flip your sheet over, or I don't know how big you write, but we're going to go do 2 more and just bump up the difficulty a little bit. So example number 2, I'm going to lead in a 3x to the third. Then I'm going to do some subtraction. So I kind of immediately bumped up the difficulty here quite a bit. But first of all, we're going to look and see, is there anything I can pull out of each one of these terms? There's a 3 and a 1 in 3. There's a 3 and 6. And you might want to check to see if there's a 3 in 45. But remember there's a trick from elementary school for knowing if 3 goes into a number. If you add up the terms, like 4 plus 5 is 9, and if 3 goes into that, it'll go into this number. So I definitely can pull a 3 out of every single term. You'll also notice that every term has some x's in it. So what that means is I'm going to divide an x out as well. So I'm dividing out a 3 and an x from every single term, and I'll put back in what I get when I divide them all by 3x. I'm going to go take my eraser here and remove this. So in case you need to physically divide it by 3x to see what you're going to get, I'm going to go do that. So I'm going to divide every term. I'm going to pull out a 3 and an x. I'm going to pull out a 3 and an x. I'm going to pull out a 3 and an x. So what happens is my x's, when I'm removing 1, I'm going to have an x squared here, because I remove 1 from there. 3 divided by 3 is 1. I'll have a minus. 6 divided by 3 is 2. X squared over x, or when I pull an x out, I get just one of them. 45 divided by 3 is 15, and the x's cancel. So I for sure have the 3x that I took out from the beginning, and now I'm trying to factor this remaining trinomial. And again, I can only lead in x and x. That takes off a lot of hassle when that happens. I'm going to go to the end and see, is there anything? Now, notice here, I'm going to need a plus and I'm going to need a minus. I'm going to have opposite signs. The first thing that pops into my head for 15 is 5 and 3. Those multiply to equal 15. But I need them to equal negative 15. So one of those has to be a negative. And I know that the negatives have to take over when I add them up. So the sign of the middle actually always goes with your bigger number. I'm going to repeat that. The sign of the middle goes with your bigger number because it has to overpower. All right, so I'm going to have a minus 5 and a plus 3. And this would be the factored form of the original polynomial. One last one that's really difficult, and then I'll be done. Let's go over here, though, too, and let's write ourselves a note. They all had an x in them. An x and a 3. So we pulled out a 3x. And I'll let you get that written down, just so you kind of understand why we chose to divide that out. We're trying to knock it down and make it something that's a lot easier to work with than that original big ugly polynomial. And again, if ever I'm going too fast or you need more time, you just go ahead. That's why we do it this way, so you can pause it and write neatly and be prepared to answer some questions on your notes. And one of the things I'm going to ask you is, what do you do first? And the answer is you look to see if you can pull anything out. So the last example, number 3. And this combines everything basically we've done in our whole factoring unit. So this one will really tell me if you know what you're doing. I'm going to ask you some questions about this. So make sure you're not just writing it down, that you're digesting it. Otherwise, you got to go back until you can answer those questions. Now, the reason this one's more difficult is we've got some bigger numbers. I did keep it all positive, though, so that was pretty nice of me, I got to admit. I am nice. Oh, dang it. All right, so the first thing I do is I look and I say, can I pull anything out of all those terms? And obviously, yes, they're all even. So a 2 could come out. But if I just pull out a 2, it'll go down to 4, 30, and 36, and those are still even. So what that means is I can pull out more than that. Maybe you might say, well, I know 8 goes into these two. 8 goes into 72 9 times, and it goes into 8 once, but 8 does not go into 60, so that's a problem. So my next guess after 2 was 8, and then that didn't work, so I'm going to try 4. Does a 4 go into 8? Yes, twice. Does a 4 go into 60? Well, I don't know. Take out a calculator and check. Because if it does, we need to use it. Yes, it does. Does a 4 go into 72? Yes, it does, 18 times. So 4 goes into everything, and I'm going to be pulling a 4 or dividing a 4 out. What that'll leave me is 2y squared plus 15y plus 18. This one makes you kind of puke in your mouth a little bit here, and the reason is because this is not a 1. So we've got to go through our step process that you've written on your, you should have a cardstock sheet, and you should open and flip to that maybe while you're, or take it out so you can kind of remember what we do in this case. First of all, the 4 is just going to hang along for the ride. I'm actually just going to go put him in my answer and then ignore him the rest of the way. So I know it's 4 times something times something. Well, let's remember our process for these. We multiply the first times the last. We break apart the existing one into y and y. And then we have to think of things that make 36. 6 and 6. No, they don't add up to 15. Oh, what else goes into 36? 2 does because it's even. Oh, crap. They don't add up to 15. 4 times 9 does, Miss Lurd. Yeah, but they don't add up to 15. So it seems like you might be kind of stuck. And what that means is you're missing something. So I always like to, when the numbers get bigger, I always think it's smart to start from the very bottom and just say 1 times 36. 2 goes in because it's even. 3 actually goes in. These add up to 9, and that's divisible by 3. You might need to take out a calculator. But 3 and 12, and that means I've just found it. So plus 3 plus 12. Once I've done that, we divide by that lead term. It's called divide and slide, so I divide, but before I slide, I need to reduce any fractions. 3 halves does not reduce, but 12 halves does. So I know this one's y plus 6, and this one I slide that out front and call it 2y plus 3. So you're ready to come up and have these notes checked. I'm going to ask you some pretty detailed questions about it, but before we do, let's go ahead and write the summary. Our big thing we do today is we ask ourselves, can I divide anything out of each term or every term before I even start? And that's my big question. And if I can, I need to do that. Otherwise, the problems get too difficult. So you'll bring these up to get checked. You'll be grabbing worksheet number 13. It is white. And listen up, because you'll work on 1 through, let's say, 1 through 8. And then the bottom 4 you can do for extra credit if you would like to. So 1 through 8 need to be done correctly. If those are good, you can move on. If you're ahead and you want to get some extra credit, you can do the bottom 4. But I'm saving the bottom 4 in case people just need a little bit more practice if they're not getting 1 through 8 right. All right, so peace out, Girl Scout.